Hello, and welcome to Algebra. Good morning. So here's a do not question. We find the slope between those 2 points. I've got the slope formula up there if you want to use that. I'm going to go ahead and hit pause on the video until you got your slope found. I'll hang out here until you're done. All right. Hey, nice work. So we're going to take those 2 points, identify the first one, -2, 6, call that point 1. So it's got x1 and y1. And the 3, -4, we're going to call that point number 2. So there's x2 and y2. On the top of my slope fraction, subtract those two y coordinates, -4 minus 6, which gives me an answer which is even more negativer. So I got -10. And on the bottom part, 3 minus -2 was a double negative. So it was like adding 3 plus 2 is 5. And then I took my -10 divided by 5, divided that. Always reduce fractions whenever you can. And in this case, it divides evenly to get -2. Cool. Today's topic is point slope form. Same thing we've been doing the last several lessons. We're going to continue with point slope form. We have those same two learning targets again today. We'll be able to write an equation if we're given some information. And the second one is we'll be able to graph a line from point slope form. So either way, for both of those two learning targets, we need to know what does point slope form look like and what are the different pieces of information in the different spots in the equation. So let's take a look what we wrote down into our notes last time. Point slope form, y minus y1 equals m, and parentheses, x minus x1. And we need to put numbers into those three different colored spots. I used colored boxes to represent them. Or if we're given an equation, those colored boxes are going to already contain numbers, and we'll need to identify this number means the y-coordinate for the green one. And this number is the slope for the red one. And this number is the x-coordinate for the blue one. All right, let's take a look at this example here. We're going to write an equation that contains the points -2, 6 and 3, -4 using point slope form to create the equation. Okay, well, it's very similar to problems that we did last time, but there is an extra step. So this time we're going to say it's a two-step process. And the first step in that process is that we will actually need to find the slope ourselves. Because this time we are given 2 points and we need to find the slope between those 2 points. So conveniently, we already did that. That's the same points that we had in our do now. And so we found the slope between -2, 6 and 3, -4 just a minute ago. The slope that we found was -2. Okay, time out for just a second. There is another approach you could have used to find the slope between these 2 points. You could take a piece of graph paper, find both of those 2 points on your graph, put dots, and then on your graph paper, you can count the squares to find the rise, how much you have to go up or down, and you can count squares going to the right to find your run. And if you did that, you graph these 2 points, -2, 6 is one dot, 3, -4 is the other dot, and then you count, you're going to get a rise of -10 going from this first point to the second, and you're going to get a run of 5. So you get the exact same numbers. You still simplify your slope fraction to get -2. Yeah, there are two different approaches, whether you use the formula or your graph. Either way is going to give you the same answer. So to write an equation, my first thing I would do is take that -2, the slope I just calculated, and drop it into the slope box. And then for the rest of the equation, I need to get a y-coordinate for my green box and an x-coordinate for the blue box. The only catch is that the x and the y-coordinates we use have to come from the same point as each other. It doesn't matter what that point is. So in this case, we're given 2 different points. We could choose either one. Doesn't make any difference. But you have to use the x-coordinate and the y-coordinate that go together. So let's start things off with this first point, -2, 6. Let's just let's say you pick that one, and so the y coordinate here is that 6. So I'm going to drop that into the green y box. X coordinate is -2, so I'm going to drop that here into the blue x box, and then there's my equation. I could clean up this double negative, and I could rewrite it without the boxes there, but there's my equation. So we'll go ahead and circle this final answer with some frosty snowflakes. It would be great for skiing. Man, if only Slope Dude were here to ski. And then I'm going to go ahead and do this again using the other coordinates. So we chose this point that I circled in yellow because I circled it in yellow, right? But what if we'd chosen to use the other point? What if we had used 3, -4? Okay, well, it still has an x coordinate. X coordinate is 3, and it's still got a y coordinate. This time it'll be -4. So we're going to take the 3 and the -4, bring them down here. -4 was the y, 3 was the x, 3 was the x. Let's make it blue so it matches. And then we'll go ahead and circle that is also a final answer. And this presents us a little bit of a quandary because typically in math, we do not have two different answers to a problem. Right? We're used to seeing a problem have only one answer, the answer, right? And so, oh, I just realized we didn't even finish this problem. We got to get the slope in there. -2. Get rid of that dot too. Okay, so let's talk about point slope form for just a second. Point slope form has some advantages and some disadvantages when we compare this form of the equation to what we learned before y equals mx plus b, or slope-intercept form. So one of the advantages is that we are not confined to just using this one special point. Right? That was true when we did y equals mx plus b. We had to have the y-intercept. It's the only thing that would work. It couldn't be the x-intercept. It couldn't be just some other random point someplace on the graph. It has to be the y-intercept. So point slope form, on the other hand, has the advantage of all of this flexibility. You can use any point you want. So if the problem gives us two different points, you could choose either one, no problem. Either one is fine. Either one is correct. But at the same time, that's also a disadvantage because now it appears that there are two totally different answers. If you look at these two answers, you can say, well, this one's got a green 6, and that one's got a green -4, and this one's got a blue -2, and that one's got a blue 3, and those are like totally different equations, right? And so the disadvantage is that it's hard for us to look at this and recognize that that is actually the same equation written twice, like with different disguises on it. So we have a couple of strategies we could use if we needed to demonstrate that those are actually the same equation. One option would be we can solve for y and rewrite those equations in y equals mx plus b form, in slope-intercept form. Okay, if we were to do that, we would get the exact same equation as a result for both of them. Whichever one of these two point slope forms we start from, they're going to get the exact same y equals mx plus b form for either one. Okay, the other option we could use is we can graph these two equations, which I did over here on the graph. So I copied those same two equations that we just got, and I graphed them both onto the same graph. So from the first equation over here on the left, I started from the point -2, 6. That's this purple dot right here, is just a tiny bit off my graph. So I guessed there's where -2, 6 would be. And then I used the slope to find the next point, which is marked by this red dot, down 2 spaces and right 1. And I drew a line there in purple from the purple dot to the red dot, and I extended it. And then I said, all right, let's graph the other point. So I started at the point 3, -4, and I did this one in tan. So 3, -4, I got to go to the right 3 and down to -4. And there's my tan dot. That's where I started from. I used the slope again to go down 2 spaces and right 1 to get the next dot, is that red dot. And then I connected those two dots and extended my line. And wouldn't you know it, but the tan line and the purple line were the exact same line. When I got my ruler, it went through all of those points. It's the same line. It's just described using two different starting points. Right? So if I start at the purple dot, it looks like the purple line. If I start at the tan dot, it looks like what's the tan line. But when I get my ruler and I extend it in both directions as far as possible, I find out it's actually the exact same line. The equations obviously look very different, but it is a representation of the same line. So those two equations are, in fact, equivalent. Okay, let's take a look at a graphing example. So in this case, I'm given an equation in point slope form and I need to graph it. In order to graph it, I need to pull some information out of this equation. So I need to get the point and the slope. So let's start with the point. So the point is going to have a y coordinate, which I can find right after the letter y. So y minus, that's part of the equation. I want to look at the number 4, which comes after the minus sign. So a different way to think about this is the equation is always going to have the opposite appearance from the actual coordinates. So in the equation, it appears that it says y minus 4. And the actual coordinate will be positive 4. So always have the opposite appearance. And the x coordinate, I'm going to look for over here inside the parentheses. It goes x plus 1. And again, it's going to have the opposite appearance. So it looks like it says x plus 1. And in reality, that means the coordinate, the x coordinate, is going to be negative 1 because that plus sign in the equation actually came from minus negative 1, and that double negative combined to make it as a plus. And so it appears to be positive. It's not. The coordinate is a negative 1. And lastly, I need to get the slope. So I'm going to put this slope here in purple, -2, and I want to have this written as a fraction so I can see the rise and the run. So -2, I will make that over 1 so I can see my fraction. Okay, starting point, -1, 4. So on my graph, I'm going to go left 1 and up 4. Here's my starting point right there, that red dot. And then use the slope to count spaces to find my next point. So the slope is down 2 and right 1. And since I'm drawing this by hand, I'm going to go ahead and repeat that process so I get more dots so I can more accurately connect them with a straight line. So from the purple dot, I'm going to go down 2 and over 1 to the right, and I'll just keep doing that, down 2 over 1 to the right until I run out of space, and then I can connect them with a line. Whoa. Okay, there we go. Scrolling the screen and it wasn't keeping up with me. So there's my line. Started at the point -1, 4 and went down a slope of -2.